Hello, junior scientists, and of course I call you junior scientists because everyone's a scientist in training. My name is Dr. Caitlin Fisher. I'm your resident chemistry nerd, and today I'm going to explain to you what does an atom actually look like. Scientists, as I mentioned, we're going to talk today about what an atom looks like. And Dr. Fisher, that's me. So first of all, we need to talk a little bit about what an atom is. So you may have learned that an atom is the building block of life. So everything that you see around you, including you, is actually composed of atoms. It's the smallest unit of an element that you can actually have. So what is an atom actually composed of? It's composed of three different things. You have your protons, and your neutrons, and your electrons. A proton is a positively charged particle. A neutron is a neutral particle, and an electron is a negatively charged particle. Although we're going to talk about this a little bit because even though an electron is called a particle, it's not so much a particle. It actually behaves more as a wave. So we'll talk a little bit about why atoms, when people talk about them, it's not completely correct. So let's draw a picture of an atom for you. So in an atom, we have two components. We have a nucleus, and we have the outside, what we call electron cloud. All right. So in the center of your atom, you have your nucleus, which is composed of your protons and your neutrons sitting right next to each other. Now, the protons and neutrons are very heavy. They compose over 95% of the mass of an atom. Now, why is this interesting? Even though they compose 95% of the mass of the atom, it's an extremely small part of the atom. So here's an analogy. Let's imagine that an atom is your football field or your football stadium. So here's your football stadium. If I took a grape and I put it on the 50-yard line, that would be the nucleus. So the nucleus is only a grape size compared to the size of an atom, which is the size of a football stadium. And yet, even though that nucleus is the size of a grape in a football stadium, it holds 95% of the football stadium's mass. So atoms are mostly empty space. Now, what is that empty space on the outside composed of? The outside is actually composed of your electron cloud, which actually surrounds your nucleus. Now, if any of you like Marvel Comics, you'll always see atoms drawn in a very particular way. So you'll have your nucleus in the middle, and then they'll always show the electrons in these orbits around the nucleus. This is completely wrong.
You would enter a reality where all concepts of time and space, become irrelevant.
Nice try, Ant-Man. Now, why is it always shown this way? It's because most people recognize an atom as having electrons in an orbit. To demonstrate to you just how deep the misconception goes that electrons orbit the nucleus, let's do a Google image search of an atom. What you'll notice here is that even as we scroll down, all of these images are incorrect representations. Wrong, 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 wrong again. But the story is actually much more interesting than that. So electrons don't actually orbit the nucleus, because electrons have something called wave-particle behavior. So wave-particle behavior. So what that means is that instead of behaving as a little distinct particle that'll actually go in orbit, electrons behave like waves. So what does that mean? Means it behaves a lot like light. So let's imagine that we think of our atom as a lantern. So here we have our lantern, and this is going to be a representation of our atom. In the center of that lantern, we have a light bulb. And that light bulb is going to be like our nucleus. Now the question is, if we turn the lantern on and it's shining light, if I asked you, where is light? You can't point at the light coming out of the lantern and say, there it is, it's right there, right? Light is diffuse, it's everywhere. Electrons behave the exact same way. So an electron is not a particle that you can just grab and hold on to and say, I found my electron. It's diffuse, just like light, because it behaves as a wave. So a true model of an atom, if we were to draw it, is that you have your nucleus, which is composed of your particles, positive and neutral, and then around it, you have a diffuse area of negative charge. So you can say, I know where the electron is, it's surrounding the nucleus, but you can't actually pinpoint where it is at any given time because it occupies the entire space at once, just like light does. So instead we say, I don't know where the electron is, but I know I have 100% probability of finding it outside the nucleus. So I don't know exactly where it is, but I know that it's 100% chance that it's hanging out somewhere surrounding this nucleus, just like light. So I can't grab it, I can't hold it, but I do know that it's taking up this entire area. So around the actual nucleus is what we call this electron cloud, or negative space, where the electron is hanging out. Now, why is this cool? Well, it turns out, and you'll learn this later in another lesson, that when you have this negative cloud, it can actually attract and bind to another atom with a negative cloud. So, if you go to your Google image search and you see an atom that has your nucleus with an electron in a perfect orbit, you can now say, that's not right. What it actually looks like is you have your nucleus, and then what we have is a diffuse negative area, where this entire area has negative charge. And that is called the electron cloud. Thank you for joining me. It's been a pleasure explaining this to you. And anytime you need to come around for something fun called quantum mechanics, you know where to find me. And now you can say, I am a quantum physicist because I now know how atoms are composed. Thank you. Can't wait to see you again.